Solids and liquids, they're everywhere. But some of humanity's greatest creations are a combination of the two. One example of this is a soft solid, which consists of solid particles and a liquid base, which when mixed together create a whole new substance with whole new properties. Some examples of this are concealer and gelatin. Now concealer and gelatin are two very different substances with several various different properties. Now this goes to show the range of different properties and different characteristics these substances can have. So, with so many different properties and characteristics, how do we quantify how individual characteristics affect the overall system? Well, that's exactly what my research focused on this summer. By looking at macro-scale particles as individuals and as small clusters, we were able to quantify and learn more about how individual characteristics of particles affected the overall coating and the overall system, or more specifically, how they affected the Cheerio effect. Now, the Cheerio effect is essentially when particles cluster together due to weight and due to surface tension. So if we pretend this is a fluid surface, and if we place a heavy particle right here, the surface will actually sink a little bit due to the particle's weight. But surface tension makes sure the surface doesn't actually break, creating a little divot in the surface of the fluid. This means when another particle comes along, it'll actually fall into this little divot and this little valley, and it'll actually be somewhat entrapped with the other particles and this distortion that they created. This means the particles are somewhat bonded to each other. And the different characteristics of these individual particles will actually determine the effect and the strength of the Cheerio effect on the overall system and in the particle-to-particle interactions. So, by looking at different characteristics of particles, such as differences in weight, differences in shapes, such as symmetric versus anisotropic particles, and differences in their short and long-range interactions, we were able to quantify and learn more about how individual characteristics affected the overall system and how it affected the extent of the Cheerio effect. So, we ended up making a few interesting conclusions. The first of which was heavier particles actually had longer range interactions than their lighter particles, which makes sense as they create a bigger distortion than their lighter counterparts. And this created a longer lasting coating on fluids, as the particles were more bonded to each other and were more resistant to strain initially. But our more surprising conclusion was that the lighter particles and the particles with more symmetric shapes were actually better able to heal themselves, which means that since they had less particle-to-particle interactions, they were able to move around more freely than their heavier counterparts, which means they were able to essentially fix any cracks that were created when the coating went under strain, as they were able to move into place. Now, with information like this, we were able to advance new fields in various industries, including biomedical engineering, cosmetics, and food science. Thank you.